Yeah, just a recap of what we did in the previous class. Towards the end of the last class, I explained you what is polar and non-polar covalent compounds. In certain compounds, certain covalent compounds, for example, HCl, the shared electron between hydrogen and chlorine is not in the exact center of the molecule. We all know that hydrogen and chlorine forms a bond by sharing of electron. But in HCl molecule, the shared electron is not not exactly in the center. Rather, it is drifted towards chlorine. Hydrogen and chlorine forms a chemical bond by sharing of electron. Okay, ideally we expect that the shared pair of electron might be lying in the center of the two atoms because each share is coming from each atom. Like hydrogen gives one electron and chlorine also gives one electron for the formation of chemical bond. Okay, therefore I ideally expected them to be at the center of the molecule, but this is not the case. We realized and we understood in last class that the shared pair of electron is not right in the center of the molecule, but it is closer to chlorine. And the explanation for that was the electronegative nature of chlorine. So since chlorine is electronegative in nature, it tries to pull the shared pair of electron towards itself, because of which the molecule gains partial charges. Charges how? We have seen earlier in case of electrovalent bond that when sodium gives electron completely to chlorine, sodium gets a plus charge and chlorine gets a minus charge. But in this case, there is complete transfer of electron from sodium to chlorine, means sodium completely loses one electron to chlorine. In this case, hydrogen and chlorine is actually sharing an electron, but the share pair of electron is drifted towards chlorine because of electronegativity of chlorine. This means chlorine is partially pulling the electron towards itself, means it is partially taking hydrogen electron, and hence such molecules develop partial charges. So chlorine has a partial negative charge and hydrogen has a partial positive charge. So if you look at the overall molecule is slightly positive from one end and slightly negative from the other end. Such molecules having opposite ends, opposite charged ends, are called as polar compounds. Covalent compounds are said to be polar. Covalent compounds are said to be polar when the shared pair of electrons are unequally equally distributed. So they are not right in the center. Rather, it is more close to one atom. The atom which attracts the electron more strongly, like in this case, chlorine is attracting that electron, develops a slight negative charge. So therefore, it has a slight negative charge, while the other develops a slight positive charge. So hydrogen has a slight positive charge. See, this happens therefore when
Yes, sir.
having different electronegativity combines together, means one is more electronegative while the other one is less electronegative. But what if the two electron atoms have same electronegativity? What if hydrogen combines with hydrogen to form a hydrogen molecule? In this case, I can say clearly that none of the hydrogen is more electronegative than the other. So here the shared pair of electron will lie right in the center. It won't drift towards one of the atom, and hence none of the atom gets any charge, partial charge. They both remain neutral. And such molecules which does not have positive and negative charged ends, which it does not have, so this does not have a positive and negative charge end, behaves like a non-polar molecule. So reading through the definition, covalent compounds are said to be non-polar when the shared pair of electrons are equally distributed between the two atoms. So those shared pair of electrons are equally distributed. One is not dictating terms and trying to pull it closer to itself. The covalent molecule is symmetrical and electrically neutral. So it does not have positive and negative ends. That's what electrical neutrality means. As I told you in last class, when there are more than one bonds in a chemical molecule, like in a molecule, then when there are more than one bonds, then just polar nature of one bond is not sufficient. Even the geometry plays an important role. How that happens, we will talk about that in the next example. So let's see the next example. Formation of water molecule. What is formula for water molecule?
H2.
H2O. It is formed by two hydrogen and one oxygen molecule. Water molecule is made up of two atoms of hydrogen and one atom of oxygen. Okay, so two hydrogen and one oxygen combines to form a water molecule. Okay, let's do the breakup of the structure. Oxygen atom has 2,6 electron in its outermost cell. So you can see oxygen atom there. It has 2 electron in the first cell and 6 electron in the second cell. This oxygen requires 2 more electrons so that it can attain the stable noble gas configuration. Noble gas next to oxygen is neon, atomic number 10. Neon has atomic electronic configuration of 2 comma 8, right? So neon is 2 comma 8, but oxygen is 2 comma 6. So if oxygen gets 2 more in the outermost cell, then it will probably become more stable. So oxygen is trying to get 2 more electron in the outermost cell, right? Okay, so in that quest, oxygen finds a hydrogen atom. Hydrogen, as we know, has only one electron in its outermost cell. So hydrogen atom only has one electron in its valence shell. So it requires one more electron to complete the duplet arrangement of the nearest noble gas, which is helium. Means if hydrogen gets one more electron, it will look like it will have electronic configuration similar to helium. Helium has only two. I think I don't need to tell you this extra that for helium or for the first cell, two is stable. Like second cell onwards, we need eight, but for the first cell, two is stable. So hydrogen just need one electron. Clear? Okay. Now moving further. So therefore, two hydrogen atoms shares one electron with each oxygen atom. So we take two hydrogen atoms, they combine with one oxygen atom. So each share one electron with this oxygen atom. We can show the sharing like this. So you can see each of these hydrogen is sharing one electron with oxygen. Okay. So here you can clearly see that, see the rule of sharing, as you know, that if you share one electron, you get an advantage of one electron. So basically, like this hydrogen and oxygen, they're sharing these two, one coming from hydrogen and the other one coming from oxygen. So after sharing, now both electrons are common electrons for oxygen and hydrogen, means both can say that this is our electron. And same, these two, this one coming from hydrogen, this one coming from oxygen, they share electron like this. Water molecules therefore has two single bonds because it is sharing one electron with two different hydrogen, right? So it has two single bond between hydrogen and oxygen. So this is how the molecule looks like. Okay, so each sharing is represented by a straight line, a bond. Is it a polar covalent molecule or is it a non-polar covalent molecule? And Vesha, what do you think? Is it polar? Does it have positive and negative ends?
So, no, it's not polar.
Quick opinion. What is water a polar molecule or is it a non-polar molecule?
It is a polar molecule.
In this case, oxygen is an electronegative molecule. Electronegative molecule means it has more tendency to pull the electron pair towards itself. So oxygen will have a delta negative charge for sure. Means it will try to pull the electron pairs towards itself. So the electron which is shared between hydrogen and oxygen are not exactly in between, but it is more closer to oxygen. So these electron pairs are closer to oxygen. Therefore, oxygen has a negative charge and hydrogens have positive charge. So this is like a polar molecule or a non-polar molecule. Maria, what do you think? It's a polar molecule or a non-polar molecule?
It's a polar molecule.
Why is it a polar molecule? Because
There are two
there are two
pairs of
bonds.
two bonds created by hydrogen and oxygen.
Okay, and both these bonds are polar in nature, and
Yes.
therefore oxygen has a negative charge. See, I want all of you to pay attention on this point, okay? Because I'll come back to this point in some time. So let's move further. Let's see another molecule which is polar in nature. So here I'll just write it down for you. This is a polar molecule. Here we can see formation of ammonia molecule. Ammonia molecule is made up of three atoms of hydrogen and one atom of nitrogen atom. Like it consists of three atoms of hydrogen and one atom of nitrogen. Hydrogen has one electron in its valence shell, so it requires one electron to complete the duplet arrangement of the nearest noble gas, which is helium. So it needs one electron. While nitrogen, as you can see in the picture there, this nitrogen having five electron in the outermost shell is looking for three more electron to stabilize the electronic configuration. Okay, so that it can have a electronic configuration similar to neon. Okay, therefore three hydrogen atom, so you can see a three hydrogen atom, they're combining with one electron, they share one electron each, so all of them share one electron each with one nitrogen atom to complete the duplet arrangement for hydrogen and the octet arrangement for nitrogen. So you can see here nitrogen is sharing three electron each with one hydrogen. Ammonia molecule therefore has three single bonds with nitrogen and hydrogen. Okay, so this is how the molecule of of ammonia looks like. Nitrogen sharing three with each hydrogen. Is it polar in nature or non-polar in nature? What is your opinion on this? Is it polar?
Polar. It is polar. It's polar
It's polar in nature. Why is it that? Why is it so, Kushi?
because hydrogen has one plus and nitrogen has electronegativity. So nitrogen takes like three electrons from each pair of hydrogen. That's why it's polar.
Okay. See here, I will. I think you are correct, but just I'll partially try to correct you. Nitrogen does not completely take electron. Therefore, it's wrong to say that it takes three electrons. It partially drifts the electron towards itself. Okay, so it partially takes, and therefore hydrogen doesn't have a minus charge. It has a delta plus charge. Delta means less than one. Okay, understood? So basically, in each of these bond, what nitrogen is just doing, like see, nitrogen and hydrogen are forming bond by sharing electron. Okay, what nitrogen says, we can't keep the shared electron here. Okay, nitrogen says let's keep it closer to me. Okay, let's keep the electron closer to me. So nitrogen keeps the electron closer to itself, and this it is able to do because it's more electronegative than hydrogen. Keeping the electron closer to itself reflects that it is partially taking hydrogen electron. Though it's not completely taking, it's partially trying to keep it with itself. So it's partially taking. And therefore, nitrogen develops a delta negative charge. Delta is a charge which is less than 1. So let's just finally see the electron dot diagram. There are two ways you can represent the electron dot diagram, as I have told you before. Uh, with nitrogen, you can draw a circle. Okay. I can just redraw it to help you understand how it's drawn. So draw nitrogen in a circle, and it is sharing electron with three hydrogens. So draw three circles for hydrogen. Okay, such that the two nitrogen is overlapping its circle with each of the hydrogen, and now hydrogen shares one with nitrogen. So this is one from hydrogen, one from nitrogen. Again, one from hydrogen, one from nitrogen, one from hydrogen, one from nitrogen. Nitrogen now even have two more electron which it is not sharing because nitrogen is only sharing three out of the five electron it had. And this is how we draw the electron dot diagram. Okay, it can also be drawn like this, where you just these are the shared electron between nitrogen and hydrogen, and this is the unshared electron. Okay, those who were there last class, can you quickly tell me what is this unshared electron known as? The pair of electron
Pair
which
of electrons.
what again? Sorry,
Lone pair.
Lone pair.
it's lone pair of electron.
Yes, sir.
And what about the pair of electron which is getting shared? This one, like for example, this pair. What is this pair called as?
Shared pair of electrons.
Shared pair of electron or bond pair of electron. Okay, next we have a methane molecule. Methane molecule again has a formula of CH4. It has a central atom surrounded by four hydrogen atom. You can see here how carbon looks like. Carbon has two in the first cell and four in the second cell. Carbon atom has 2 comma 4, has 4 electron in its outermost shell and requires 4 electron to attain the stable electronic configuration of the nearest noble gas neon. Okay, it has 4, so it needs 4 more. And hydrogen, the same old story. It has 1, so it needs 1 more. Okay, so here one carbon combines with 4 hydrogen atom and it shares 1 electron with each hydrogen atom to form a methane molecule. And this is how the sharing looks like. The methane molecule has 4 single bond between carbon and hydrogen. So okay, so that would look more like this: carbon sharing 1 electron with 4 hydrogen. Okay, next question for you. What is nature of methane molecule? This you already know. You understood, no? No problem. How the sharing is happening here. So my final question for you is about the polarity of molecule, methane molecule. Is methane molecule polar in nature or is it non-polar in nature?
Yes, it's non-polar.
Non-polar?
Yes,
Why?
sir, it is non-polar. Or like there is like little bit difference of electronegativity between the two molecules.
The two atoms, carbon and hydrogen, has negligible electronegativity. That's what your point is.
Yeah, like there is less like difference between the two.
So therefore, the
Or
bond
is
is
it
not.
because the hydrogen atoms are distributed evenly?
Even that is a good point. But was that not evenly distributed in the other cases like water and ammonia?
It wasn't distributed evenly in water, even in ammonia.
Oh, yeah, there are 2 points. Which one point raised by Anvesha is that so they are not polar because carbon and hydrogen has very little electronegativity difference. Uh, I would say that both points are correct. Even what Gun is saying, that symmetric distribution is also correct. And also that they have very little electronegativity difference, carbon and hydrogen. Therefore, this is not slightly negative and positive because the since the electronegativity difference is too less, the shared pair of electron is almost in the center for all the four bonds. Clear? Okay, let's move further. Let's see that. So this is the electron dot diagram for methane, where each carbon is sharing one electron with hydrogen. In that circular notation, if you want to draw, like using the circles, you can draw it like this.
Um, so
Yeah,
I think for like one atom we can like use the X as electrons because you won't get confused.
yeah, that's also fine. So for hydrogen, I'm showing it as a X here, and carbon with a dot. So this is structure of methane molecule. Clear? Okay. So for electron dot diagram, one of this is acceptable. All right. Let's move to the next molecule, which is carbon tetrachloride. Okay. Carbon tetrachloride, like methane, is a compound between carbon and 4 chlorine. In methane, it was carbon with 4 hydrogen. So here we have carbon with 4 chlorine. Okay, and again, like hydrogen needed 1 electron, even chlorine needs 1 electron. Okay, so you can see here again, carbon has 4 electron in the outermost shell, so it needs 4 more electron for stable electronic configuration. While chlorine has 1, 2, 3, 4, 5, 6, 7 electron in the outermost shell, so it needs 1 more for the stable electronic configuration. Okay, therefore the 4 chlorine atom mutually shares 1 electron. So carbon shares all its 4 electron with 4 chlorine atom, which you can see by the bond diagram here. So carbon shares its electron 1 electron with this chlorine. It shares the second electron with the second chlorine. It shares third electron with the third chlorine, and it shares fourth electron with the fourth chlorine. Okay, sharing 4, carbon gets a benefit of 4, so it's now 4 plus 4. Okay, it's 4 plus 4, it's neutral, like 8. And chlorine, which had 7 earlier, now gets 1 more, so it is 8 now. So 7 plus 1, 8. And this also 7 plus 1, 8. 7 plus 1, 8. Okay, and as I said, for carbon, it had 4, so it is sharing 4, 4 plus 4, 8. This way we see that octet for each element, that is carbon and chlorine, is completely satisfied. Like, what is the nature of the molecule? Is it a polar molecule or a non-polar molecule?
Sir, is it non-polar?
Non-polar. And what is your explanation for that?
Uh, is it because they're all symmetrical?
Okay. I have another question for you. What is your comment on the bond between carbon and chlorine? Is the bond polar in nature or not? Is it polar? The carbon chlorine bond?
Carbon chlorine.
Yeah, this bond here.
So you mean
Uh,
one carbon and one chlorine?
Yeah, I mean one carbon and one chlorine. That bond between one carbon, that carbon and one chlorine, is that bond polar in nature or not?
is it polar?
It's polar.
It is polar in nature, yes. Okay. So see, chlorine is electronegative in nature. So in this bond, if you look right, the electrons are drifted towards chlorine, and hence chlorine has a negative charge, partial negative charge, and carbon has a positive charge. And that is true for all the chlorine. All the chlorines have slight negative charge, and carbon has a slight positive charge. So every single bond here is polar in nature. Okay, so every single bond is polar in nature. But when we talk about the overall molecule is non-polar. And the correct answer for that is the symmetric distribution of bonds, these polar bonds. So whenever polar bonds are symmetrically distributed, then the overall molecule does not have polarity. Now, the other way of explaining it, like carbon tetrachloride molecule, carbon is in the center and chlorines are along the corners. And the center is positive charge while these are negative charge. So if you approach this molecule from outside, like from any direction, you are more likely to find the negative. So it's negative from all the sides and positive is in the center. Okay, so if you look at this overall molecule, from outside it is negative because all the like chlorine is distributed in all the directions symmetrically, and it is positive in the center. Such molecules are not called as like polar. They are actually non-polar. Then what is polar molecule? Polar molecules are molecules which are positive from one side and negative from the other side. For example, if I look at water molecule, see in water molecule is actually like this. It is bent structure. If water was like this, if I assume that water was like this, okay, then in this case oxygen, the negative is in the center and positive is like ours on the corners. Okay, one such example is beryllium chloride. You'll study about this in higher classes. In beryllium chloride, the two chlorines are right opposite to each other. So beryllium has slight positive charge and chlorine has negative charge. Okay, this molecule is non-polar. This is not polar because it is not positive from one side and negative from the other side. And has water structure been like this, even water would have been non-polar in nature. But somehow this is not the correct structure of water. The correct structure of water is a bent molecule, means oxygen like this and two hydrogen bent a bit. So it's not straight vertically opposite, it's bent like this. Okay. Therefore, this side hydrogen side is slightly positive while oxygen side is negative. So from this side molecule overall is positive and from this side molecule overall is negative. Okay, so if you have let's say like two bonds, polar bonds, okay, two polar bonds, but they are right opposite to each other. Okay, right opposite to each other. Then the molecule is not polar because these bonds are symmetrically arranged. Like two things, how can you arrange them symmetrically? Keep it right opposite to each other, right? So in that case, it is not polar in nature. But if the two polar bonds have some angle between them, which is not like 180 degrees, some other angle, then it is polar in nature. Okay, whenever there is more than two polar bond in a molecule, the only way to decide that the polarity is by understanding its structure. Okay, so this is how the water molecules look like. This is how generally we draw. Sometimes we draw it bent, sometimes we draw it straight, our wish, right? But in reality, how water molecule looks like, okay? So in real water molecule, the hydrogens are bent, okay? And now since it is bent in shape, this oxygen side is slightly negative and the hydrogen side is slightly positive. So from one side it is positive and the other side it is negative. Am I clear?
Yes,
Yes.
sir.
Let's try to see another shape, which is okay. This is ammonia. So this is how the ammonia molecule actually looks like. Can you see they are not flat?
Yes, sir.
Yes, sir.
We try to keep it in 3D. You see that it's actually bent towards one side. Okay. Uh, if ammonia was a flat molecule, then it would probably be a non-polar molecule. But because it's not flat, so this overall molecule in this case, this side is all positive hydrogens, and this side is negative negative nitrogen. So from this side it's negative, and this side is positive. Okay. If this nitrogen was a flat molecule in 3D, ammonia was a flat molecule, like in one plane we had nitrogen and three hydrogen, then it won't be polar in nature. But because it's not a flat molecule and it is a little bent towards one side, so and the nitrogen is bulging towards the other side, so the nitrogen side is more negative and the other side is more positive. So let's move to the next compound, methane. We saw methane or carbon tetrachloride, for example. Carbon, now this is connected to 1 chlorine, 2 chlorine, 3 chlorine, and 4 chlorine. Okay, here carbon is missing. Yeah, now okay, that disappeared. Now I brought it back. So this is carbon with 4 chlorine. So in 2D, I have drawn as I like randomly. I did not pay much attention, or I did not try to make it perfect. I just randomly distributed the 4 chlorine, and that is fine for the 2D diagram. But in reality, how this actual molecule looks like? So this is how the actual molecule looks like. Okay, even in your textbook, they have drawn it like in a plane of paper, which is not correct technically. Okay, this is how the molecule look like. Here you see the middle is carbon, and there are 4 hydrogen from all the sides. But here you see there is a perfect symmetric distribution around the central carbon. Okay, from each side the chlorine is distributed, isn't it?
Yes, sir.
Yes.
Okay, therefore this carbon is positive here and the chlorines are negative here. So the overall molecule is negative from all the sides and positive is in the center. And so it's a non-polar compound. Okay, we have studied ionic bonding, where we studied that there is complete transfer of electron from one atom to the other atom. Then we saw covalent bonding, where there was sharing of electron. In covalent bonding, we further saw polar and non-polar covalent bonding, where there is uniform, fair sharing and unfair sharing of electrons. And then finally, we reach to a last part of the last type of bond, which is coordinate bonding. Okay, so a coordinate bond is a bond which is formed by shared pair of electron with both electrons coming from the same atom. Suppose if A has an electron and B has a, like A is like A had an electron, A completely gives this electron to B. Okay, so in this case, what happens? A loses electron and B gets a gains an electron. Like it gets a benefit of electron. Second case we saw in covalent bond where A and B both are sharing one electron. So if they're sharing electron, sharing means both can claim that this is our electron. So in this case, A gets a benefit of electron and B also gets a benefit of one electron, right? Like for example, if sodium and chlorine. So sodium has one electron and chlorine suppose had seven electron. One, two, three, four, five, six, seven. So here sodium loses one electron, and so in the outermost cell it gets zero, right? And chlorine gains one electron, so from seven it becomes eight, right? From this, in sharing of electron, for example, hydrogen and chlorine again. Chlorine has seven in the outermost shell, hydrogen has one in the outermost shell. If they share one, then hydrogen gets one more. Like it can say chlorine electron is also its electron. And chlorine also gets a benefit of one. So both benefits in this way, right? So this was ionic
Yes, sir.
and this is covalent. Third type of bond is coordinate bond. Now see what happens here. In coordinate bond, A has two extra electron. Okay, it can have two or more extra electron, which it is personal electron of A. And B needs two electron. Okay, so A tells B that I will share electron with you, but you don't worry about giving your share. Both the share will be given by me. Means after this, A does not benefit anything. Okay, A stays where it is. There is no plus or minus because A's electron is still with A. Okay, A is not giving it to B. It's not ionic bond that A is giving it to B. A electron is still with A, but it tells B that if you want, you can also use it. I can give you two electrons to use. So B gets a benefit of two. So this is a story of formation of hydronium ion. Let's try to understand hydronium ion formation so that you really understand what coordinate bond is. Okay. Now hydrogen and chlorine forms covalent bond between them. Means both are sharing one electron. Can you tell me after sharing what is electronic configuration for this hydrogen? It had one and it is sharing one, so it gets two, right? and chlorine has 7, so it shares 1, it gets 8. The nature of bond between them is covalent in nature. Now you know what happens if I dissolve this like this HCl in water. In water, somehow chlorine becomes a little bit strong, and uh, how this happens, let's not get into this. Just understand this like a story. So inside water, chlorine becomes a little strong and becomes a little bit more greedy also. So inside water, when you dissolve HCl in water, chlorine completely pulls this electron from hydrogen. Means it takes its electron and also takes hydrogen electron. So from a covalent compound, it turns into an ionic compound. So this hydrogen completely loses its electron to chlorine. So hydrogen becomes plus one charge and chlorine becomes minus one charge. This is a very important process and it is called as ionization. This way chlorine now still has 8, but hydrogen, poor H plus, has how many? 0.
Then, so how can it have a charge if it's zero?
It has a charge because it does not have an electron. It has lost its electron. See, hydrogen electronic configuration is 1. Chlorine electronic configuration is 287. So one option is they share this one, hydrogen shares 1 with one of this chlorine, and so that this becomes 8 and this becomes 2. And that happens during the formation of covalent bond between them. But inside water, the nature of bond changes. Inside water, chlorine convinces this hydrogen to completely donate electron, and hydrogen becomes 0, chlorine becomes 8. Okay, so here now there is complete transfer of electron. So whenever electron is completely transferred, the species which loses electron becomes positive charge, and the one which gains electron becomes negative charge. Is that clear?
Okay. Okay, yes, sir. So hydrogen has no protons, no electrons.
No electrons now.
Okay.
But then there was actually a different part of the story. It's not that chlorine was able to pull electron from hydrogen just because of its strength, but hydrogen also had some other hidden motives. Okay, there was another side to this story. As soon as this H plus, when it got separated from chlorine atom, okay, this hydrogen never lived stayed alone. It's not that it got separated from chlorine and it became alone like a positive cation. Okay, even before giving electron to chlorine, H plus had already made its arrangement. Okay, there was another arrangement, so it just feels like we were unnecessary basically feeling sorry for this hydrogen, that it is completely losing its electron to chlorine. But the real side of the story, or the other side of the story, says that hydrogen was already pre-planned with another clever strategy. When it entered water, it realized that water is basically a covalent molecule between hydrogen and oxygen, where oxygen is sharing two of its electron with two hydrogen. Okay, but oxygen also has two lone pair of electron, which is personal electron of oxygen. Okay, these are what personal electron. Okay, let me draw that a little big so that we understand better. So this is water molecule. In water molecule, oxygen is sharing two electron with each of these hydrogens, right? And it has two lone pair, which is personal electron of oxygen, correct? So only oxygen has control over these four electrons, two lone pair of electrons. So when HCl entered water and H plus got separated, it has already seen that oxygen has a lone pair. So as soon as it loses its electron to chlorine, it runs towards water molecule. And it convinces this oxygen that let's have a sharing in which both the share come from you, because I have no electron. I have given my electron to chlorine. So I cannot contribute in the share. So this is water molecule where oxygen has two lone pair of electron. H plus came alone without any electron because electron is with chlorine. And it requests this oxygen to form a bond with itself where both the shared pair of electron must come from oxygen. Hydrogen has nothing to share. And oxygen even gets agrees to this idea, and therefore oxygen share one of its lone pair for a formation of bond with H plus. Okay, and like the H came with a plus charge, right? So that plus charge we can write together for the whole species outside, means together they have a plus charge. This what you see here is a hydronium ion, and in this case this bond which you see between oxygen and hydrogen is a coordinate bond. These two are covalent bond because in this the two shared electrons are coming one from each oxygen and hydrogen, while the third bond is a coordinate bond because here oxygen is donating its lone pair for the formation of bond with a H plus ion, and such bonds are called as coordinate bond. So coordinate
Yes, sir.
bond is a type of bond where the shared pair of electron comes from one atom, not from both the atom. One gives both a share because the other one here, as you saw, did not had an electron only to donate it. So if at all bonding has to exist, it's between H plus. It is the share has to come from oxygen only. Okay, so let's quickly finish this now. Then okay, here the equation is written. The distribution of electron I already explained you, but this is how it is actually written. Okay, for if they ask you to draw the electron dot diagram or the diagram for the formation, electron dot diagram for the formation, you can draw it like this. Here, draw water molecule, oxygen 2 lone pair of electron, hydrogen, hydrogen plus H plus. Okay, this lone pair is used for the formation of coordinate bond with H plus. So finally, oxygen 2 or pre-existing bond with hydrogen, one coordinate bond with H plus. Oxygen still has a lone pair left. Okay, and overall, I put a positive charge. Okay, this charge came with this H plus, but because now it's this whole thing is one species, one big species, I'm saying overall they have a plus charge. This whole structure can be condensed and written as H3O plus with a plus charge. Okay, if you understood this, you will quickly understand even this. As you remember, in ammonia molecule, nitrogen has a lone pair of electron. Basically, nitrogen had 1, 2, 3, 4, 5 electron, out of which it is sharing 3 with 3 hydrogens. And it has a lone pair which is free. So nitrogen can share that lone pair if it wants with someone to form a coordinate bond. Okay, so nitrogen shares that lone pair of electron with another H plus ion. Okay. Again, the similar arrangement is worked out because H plus does not have any electron, so it requests nitrogen to only give both a share, and nitrogen has a lone pair, so it's fine with it. Okay. So nitrogen gives the lone pair for the formation of bond, and then we get the final ammonium ion NH3 and a lone pair with another hydrogen, and this is overall a positive charge. The compound that does not have lone pair of electron is water, ammonia, carbon tetrachloride. Which compound does not have a lone pair of electron?
Carbon tetrachloride.
Carbon tetrachloride.
Okay. So water and ammonia, we just now saw they have lone pair of electrons. So carbon tetrachloride, carbon is sharing all the electrons. But I think that is also not correct because carbon does not have a lone pair, but chlorine does have a lone pair, right? Isn't it?
Yeah.
They should
Then
have.
it's water. It's water, right?
No, I feel that all the options are wrong. Okay, I took this question from your textbook only, but I think all the answers are wrong here. Carbon has chlorine, like 4 bonds with chlorine, and carbon does not have a lone pair, but chlorine do have a lone pair of electron, isn't it? So I think if we change this from carbon tetrachloride to methane, then methane would be a correct answer because in methane there is no lone pair of electron. Correct? Okay.
Yes,
Water,
sir.
water and ammonia is 100% wrong because water may oxygen has two lone pair, ammonia has one lone pair, and that's how they form the coordinate bond. Okay. Or other way of correcting this question could have been like the compound which does not have lone pair on the central atom. Then carbon tetrachloride is correct. Next question: electrovalent compound have high or low melting point?
High melting points.
High melting point.
High
High
melting point.
melting points.
Yeah, like NaCl has high melting point. Salt. The molecule which contains triple bond, hydrogen, ammonia, nitrogen.
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 Very good. W, X, Y, and Z have electronic configuration. W has 1, X has 7, Y has 5 in the outermost cell, Z has only 1. What is the type of bond formed between W and X?
Electrovalent.
W and X is electrovalent because W gives 1
Yeah.
and X takes 1. And Y and Z? Y and Z? Z is 1, but it is not a metal, it's a non-metal, hydrogen, isn't it? And Y is 2 comma 5, that's nitrogen.
Nitrogen. Yeah.
So nitrogen and hydrogen, what's the nature of bond? NH3, ammonia.
Covalent?
Covalent.
It's covalent.
Yes, it is covalent. See here, the point which you need to remember is uh, only if it has one electronic configuration, means it's hydrogen, then treat it like a non-metal. Otherwise, for anything else, 2 comma 1 3 2 comma 8 comma 1 2 comma 8 comma 8 comma 1, those you can take it like a metal. But if it's only one, it's hydrogen, it is a non-metal. Okay. The formula of compound between X and Z. See, X has a valency of
7.
7 valence electrons, so valency is -1. Z has 1 electron, so it has a valency of +1. So the compound cross multiply, and since Z is a cation, you write,
XZ.
see, mostly it's a cation, no? So we write the cation first. Like hydrogen is a cation with respect to X, so we can write ZX. Cancel, cancel, because they have same valency, plus and minus. Okay, W is +1 again, and what about X here? -1.
-1.
So it is WX again. Clear?
Yes, sir.
There are many more questions we will discuss in the next class. For today, we'll end it here, and we'll see more in the next class.